All right. Good morning, Kaylin.
Good morning. How are you?
I'm doing good. Really excited to dive into our coaching conversation today. And before we really get too deep, I want to recognize several strengths that I observed during your lesson.
Okay.
You've established strong classroom routines that allow students to transition smoothly between activities and use their materials independently. I also noticed that students were consistently engaged in partner discussions, and you created a classroom environment where students felt comfortable sharing their thinking and persevering through challenging tests. What impact do you think those routines and classroom structures have on students during their math instruction?
Well, thank you, first of all, for acknowledging all those things. I didn't even see
Yes.
that in the moment, but it's great to hear. I think that my students know what's expected of them. And because of that, they can focus on solving the math instead of figuring out what the
Mhm.
procedures are. I think they feel comfortable working with partners and sharing their ideas. So, because of that, that makes them kind of more willing to participate and persevere when they feel like challenges, like feeling challenged. So, I think that those routines and those relationships create that strong foundation for learning math.
Absolutely. I definitely agree. And that's a testament to the hard work that you've done to create that environment in your classroom.
Thank you.
You're welcome, of course.
Mhm.
So, based on the lesson that I observed, today we're going to focus on delivering a focused, explicit model
Okay.
that builds student understanding of division as repeated subtraction and supports their ability to perform the procedure accurately and independently.
Okay, that sounds good with me.
All right, perfect. This is really important because it drives students develop stronger conceptual understanding when they first see and hear the mathematical reasoning behind the strategy. An
Mhm.
explicit model really helps students understand not only what to do, but why the strategy works before they're expected to apply it on their own. So, we are about to observe an explicit model in action. And as we do, I'd love for you to pay attention to how the teacher makes the mathematical thinking visible. We always want thinking to be visible for students so they can replicate it. And let's start by thinking about why you think we chose those moves or why those moves matter for students. Okay?
Okay, yes. Um, for me, it's important that my students understand the reasoning behind the strategy before they're expected to solve it on their own. So, seeing the model or seeing me model the thinking, it really helps them make connections between the story problem, the
Mhm.
drawing, the repeated subtraction. I think an explicit model gives students a clear example of the mathematical thinking that we want them to use during their practice.
Yeah, absolutely. I really like that you named the connections. The connections are really helpful for students as they're forming that new learning. So you're spot on, and it really does build understanding before asking students to apply the concept independently. Let's think back to the lesson that I observed. When you compare it to the model we just discussed, what are some things that you notice?
Well, I did give students opportunities to solve the problems with partners and share their thinking, but I don't think I clearly modeled how repeated subtraction connected to the division situations before asking them to begin working. So that's clear to me.
Yeah, that's fair, and that sounds about right. Is there anything else that stands out to you?
Yeah, so in the model that you did, you connected the context, the representation, and the repeated subtraction number sentences while thinking aloud. And then I noticed the quick check for understanding that you did before the students began their independent practice. So in my lesson, as I reflect, several of my students were unsure about what they were supposed to do, and I
Mhm.
spent time helping individual students. But in hindsight, I think some of that confusion could have been prevented if I had modeled the mathematical reasoning first for everyone.
Yeah, I think that's a really good reflection. We always want to support students where we see that they're at, but if we can
Hmm.
support them on the front end with an
Right.
explicit model, that's going to help them as well. So, what impact might that have had on your students' understanding of the lesson objective if you did provide that think aloud up front?
I think that they may have been able, they being my students, may have been able to complete parts of the task, but they may not have fully understood why repeated subtraction represents division. So
Mhm.
some students were probably following procedures instead of making the mathematical connection.
Yeah, we love procedures. They're
Yeah.
important. And we also want to make sure that they truly understand that repeated subtraction is division and what that looks like and what that feels like and what that sounds like. But you're exactly right. When students don't first experience a clear model of the mathematical reasoning, they're more likely to just rely on guessing,
Hmm.
or just using those procedures that they're not quite understanding because they don't have an understanding of the underlying concept.
Yeah.
But based on what we've discussed, what is one instructional move that would have had the greatest impact on student learning?
Um, And so I think, as we stated, like providing that focused, explicit model
Yep.
before releasing the students to practice, I think that would have helped them understand more of how repeated subtraction and division connects, and prepare them to engage in the independent practice more successfully because, like I said, some of them like struggle through that part.
Yep. I definitely agree. So, based on our discussion, I think we've identified the highest leverage opportunity for growth. And now we're going to move into naming it with our action step.
Okay.
All right. So, based on what we've discussed so far today, what do you think your action step should be?
I think it should be to provide a focused, explicit model that clearly shows how repeated subtraction represents division before asking them to solve problems independently. So big picture is explicit, clear model.
Absolutely. You got it. You absolutely got it. So based on the evidence from the lesson and our discussion, we'll break the action step into the what, which is the big piece, like what is the big step that we're working towards, the how, which of course will tell us how to get to the what, and then as evidenced by is like what is the evidence showing that we were able to accurately implement the action step. So
Okay.
for the what, we're going to deliver a focused, explicit model that connects division situations to repeated subtraction before students begin independent practice. And for the how, essentially just start with a clear objective and connect it to what students already know. Use one strong example to unpack the mathematical thinking and then pause for a few targeted checks for understanding and
Mhm.
quickly transition students into doing the reasoning and problem solving themselves. So that will be evidenced by essentially students should understand not just what steps follow, but why those steps make sense. They
Okay.
should be able to explain the connection between division and repeated subtraction and apply that thinking independently with minimal confusion. Okay, so let's write down those key components. Can you tell me in your own words what you'll be focused on during your next lesson?
Yeah, so I thought about it, and before I have my students begin solving on their own, I'll intentionally model one representative example and explain my thinking out loud. I'll connect the story problem, the drawing, and the repeated subtraction sentence so that my students will understand why the strategy works, not just what steps to follow. I think that's important.
Okay, yes, I'm with you. And then what evidence will tell us that this action step is being implemented successfully?
I think that they should be able to explain how repeated subtraction, I feel like I keep saying this, but it's so important.
Yes.
How repeated subtraction represents division before they begin their independent practice.
Hmm.
And then while they're working and while I'm circulating, I should hear them using that math language from the model and making
Yes.
connections between the story problem, their drawings, and the equation.
Yeah, absolutely. And it's just like the key point of a lesson. We say it over and over again.
Hmm.
Repeated subtraction is division. Repeated
Yep.
subtraction is division. You're
Yep.
you're on it. You're definitely on it. Exactly. So we want students demonstrating the conceptual understanding, not just completing the procedure.
Hmm.
And okay, so how clear do you feel on your action step right now?
It feels so clear.
Good.
It makes perfect sense. So I know that I need to spend more time making the mathematical thinking visible before they begin practicing on their own.
Excellent. So now we can move into the planning and practicing how you'll implement this in your next lesson.
All righty.
Okay, so let's actually do it.
All right.
You can go ahead and take out your next math lesson, which should be lesson 9.
Mhm.
And looking at this lesson, where do you think an explicit model will have the greatest impact on student understanding?
So for this lesson, I kind of looked through it and I think it should happen before the students begin solving the first problem independently. I want to clearly model the mathematical reasoning before asking the students to apply it on their own.
Yep, I totally agree. And what are the most important mathematical ideas students need to hear you think aloud during this specific model?
I want them to understand why we're subtracting the same amount repeatedly.
Mm-hmm.
I'm going to explain that each subtraction represents one equal group from the story problem. I
Yep.
want to make that very clear. And then I'll connect that thinking to the drawing and the repeated subtraction equation.
That sounds like a perfect place for a model. So what will you be doing before releasing students to practice to make sure that they're ready?
I want to ask some questions to check that students can explain how the repeated subtraction matches the drawing and the story problem before they begin solving independently. That'll give me an idea of whether they understand the concept or not.
Okay, I think this is a solid plan. And those checks for understanding will give you valuable information about whether students are ready for independent practice or if they need additional support. So now let's go ahead and
Hmm.
rehearse the explicit model together before you teach it to your
Oh no.
students. Yes,
Okay.
you are so ready. You're on it.
Okay.
So for our first round of practice, like I said, we're just going to open up lesson 9.
Okay.
And we will use a number line to describe um, the lesson calls for students to use a number line to describe division
Okay. Mhm.
and relate it to repeated subtraction. So before students begin solving independently, you'll have an opportunity to deliver an explicit model that makes that mathematical reasoning visible. We always want it to be very visible and clear. And let's just pretend I'm one of your students, and you can go
Okay.
ahead and teach the beginning of the lesson, starting with that train cargo problem. And I am here. Let's do it.
All right, let's do it. So you're going to be my student, and I'm going to act like I'm actually teaching this to you.
Yes, your
All
kid.
righty. All right, class. So now it's my turn. And you know when it's my turn, it's I'm talking and you're looking and listening. Okay. So I'm going to put on my thinking cap. That's our signal of you're looking and listening, and it's my turn. All right. Today, we're going to learn how a number line can help us show repeated subtraction in a division situation. The train conductor has 12 boxes. She put 2 boxes in each train car until they are all gone. We need to figure out how many train cars she uses. I'm going to start by placing 12 on the number line because that's how many boxes we have all together. So we have 12 all together. Since two boxes go into each train car, I'll subtract two each time. Each jump you see of two represents filling one train car. As I subtract two over and over, I'll keep track of the jumps until I reach zero because that means all of the boxes have been placed into train cars. Now I'll count the jumps. There are six jumps. So the conductor used six train cars.
Awesome. Let's pause there. So great job
I was
jumping.
nervous.
I know, great job jumping right in. Awesome. So I
Thank
noticed that
you.
you clearly explained what you were doing as you modeled the number line.
Hmm.
You made a lot of connections to what each piece represented. One place I'd like you to try again is making a connection between the number line and the repeated subtraction, even more explicit.
Okay.
So students should hear you explicitly connect each jump on the number line to equal one group. So
Okay.
you said that each jump was two boxes, but let's make sure that we're connecting to say that that's one group. And
Okay.
they also
Okay.
need to hear that the total number of jumps tells us how many groups or train cars there are. So let's try that section one more time.
Okay. So just that specific section.
Yes.
Okay. And scene. Okay, so as I subtract two each time, I'm taking away one equal group because each train car holds two boxes. Every jump on the number line represents one train car being filled. When I reach zero, I'll count the jumps to determine how many train cars were needed. That sounds about right.
Fantastic. That was a
Okay.
fantastic upgrade. Great job implementing that feedback right away. That explanation makes the mathematical reasoning much more visible and
Okay.
clearly connects the number line to the repeated subtraction. So great job there. Okay,
Whew.
yes, take a deep breath. You did it. And we're going to do one more round. And then in this round, let's use one of the misconceptions that's already embedded in lesson nine, that's anticipated. So as we practice one more time, I want you to imagine that a student says, I don't understand why we start with 12 on the number line, on the
Mm,
right side of the number line instead of zero. Okay, so
mm.
one more time. The student says, I don't understand why we start with 12 on the right side of the number line instead of zero. So this time when you practice, I want to hear how you would respond to that question.
Okay.
Okay?
All right, thinking cap on and scene. That's a great question. We begin with 12 because that's the total number of boxes we have before we start putting them into the train cars. Since we're taking boxes away by placing them into equal groups, the number gets smaller each time. So our jumps move towards zero. If we were adding boxes, our jumps would move to the right side instead. That makes sense?
Yes, excellent. That was excellent. So you connected the movement on the number line to the context of the problem and helped students understand why the jumps move towards zero with that subtraction rather than simply telling them where to start. That explanation reinforces the mathematical reasoning and prepares students to use the number line independently. So
Got it.
let's take a moment to reflect on your practice. What felt different about delivering this explicit model compared to the lesson that I observed?
This time, I spent much more time making my mathematical thinking visible instead of moving quickly into student practice. So I basically intentionally explained why each jump on a number line represented one equal group and
Mhm.
how that connected to repeated subtraction.
Yeah, I noticed that too. How do you think those changes will impact students' understanding during the lesson?
I think the students are going to have a clearer understanding of what the number line represents before they begin to solve on their own. Instead of trying to figure out both the strategy and the problem at the same
Hmm.
time, they'll have a model that they can reference as they work, which in the last lesson, they didn't necessarily have that.
Yeah. And this is an upgrade. So exactly,
Hmm.
exactly, exactly. Tying back to what we said at the beginning of our time, an explicit model gives students a foundation for success by making the mathematical reasoning visible before they're expected to apply independently. And as you think about today's rehearsal, what is one part of your explicit model that you'll be intentional about including in your next lesson?
Let me think. So I'll definitely be more intentional about thinking aloud as a model. I want the students to hear why I'm subtracting the same amount each time,
Hmm.
how each jump represents one equal group, and why counting the jumps help us determine the number of groups.
Yes, absolutely. That'll make something like subtracting that students are familiar with, make it
Hmm.
more connected to division. Absolutely. And that sounds great. So those intentional think alouds will help students connect the context of the problem, the number line, and the repeated subtraction in a way that builds conceptual understanding. All
Hmm.
right. So let's lock in today's learning. What should I see in your upcoming lesson related to your action step today?
Well, you should see me deliver a more focused, explicit model before students begin their independent practice. I'm going to make my mathematical thinking visible by connecting the problem context, the number line, and the repeated subtraction. Before students begin working independently, I'll also use a quick check for understanding to ensure they're ready to apply the strategy.
Great. So, I'm planning on coming back this Thursday, so I'm really looking forward to it.
Me too, I'm excited. Thank you,
Awesome. Well,
Jack.
thank you very much, Kaylin, and we'll talk soon.
All righty.